So there are a couple of different kinds of geothermal energy. Historically, we've seen them in campus-type settings where you've got a bunch of buildings and they share a common energy infrastructure. And that's worked really well, and it will continue to work really well, where there is one owner that owns all of the properties that go around it. But the whole concept behind the utility thermal energy network is that we're now working to connect multiple independent-owned facilities and structures.
On geothermal projects, it is the ground is the central plant that produces the energy. The central plant would be one that actually allows energy to be shared by different customers, and it basically allows for heating and cooling to be utilized across multiple users.
We use the ground to capture that heat in the summertime and store it for use in the wintertime, and vice versa.
So for this project, there's an ambient loop in the ground that runs anywhere from 30 degrees to 90 degrees Fahrenheit, which is then exchanged with the buildings connected through a heat exchanger from the ambient loop to the building distribution loop. And that building distribution loop is distributed out to the heat pumps located within each building. So the heat pump takes that building distribution loop, that working fluid, and uses a compressor and an expansion valve and a refrigerant to then take out that heat or reject heat and then heat and cool your building.
What's really neat about thermal energy networks is that you could be an off-taker or a supplier, right? So say I need energy for heating. I can pull BTUs out of the system. I can use them to heat my building. Well, what if I'm a data center or I run a bakery or something where I have some waste heat process? I can take that excess energy and put that into the loop that somebody else can then take beneficial use out of.
So another thing for this project that's very important was making sure that we had the appropriate modeling in place. The backbone of this project is the modeling.
So we not only modeled the energy loads for the buildings connected right now, but we also modeled the buildings that the utility would connect in the future.
It took a lot of reruns, a lot of checking to make sure that we had all of our right pump calculations. And on top of that, it takes coordination across multiple disciplines to have the right size equipment. And once that equipment size, we have to make sure we have the right amount of electricity running to that equipment. We have to make sure this works at point A and it'll also work at point Z.